4, median of two sorted arrays. So we are having two sorted arrays, nums1 and nums2, of size m and n respectively. We're going to return the median of the two sorted arrays. The overall runtime complexity should be log n plus n. Yeah, if we were to realize this kind of a time complexity, normally it's gonna be use a binary search because we're gonna use the log time. Yeah. So for example, if we can use nums1. So if nums1 is a, so we have 0 and 3, and nums2 we're gonna define it as b. B has this array 2, 4, and 5. Yeah, so how can we solve it in O n plus n time? So if it is one array, so we need to combine two arrays to be one array. Yeah, maybe we can use n plus n time. So if the length of the array is n plus n, if we can use a binary search, normally the time complexity should be log n plus n. Yeah, so this means we have to use a binary search for the array A and array B at the same time. Yeah, but we cannot use a binary search in two arrays, but we can use a binary search in one array. So for example, we're gonna choose the shortest array. So for example, the shortest array is A, so we're gonna choose the shortest array A as our binary search, and then we're gonna find the midpoint. So for example, the midpoint is 0 because this index is 0. The right index is 1, 0 plus 1 divided by 2, so the midpoint is 0. And then we're gonna split it as this position, it's gonna be 0. Yeah, what we need to do, we need to find another split inside the array B. Yeah, so for this kind of split, we need some mathematical calculation. So we're gonna use a variable half. So it is 8 as half. Yeah. So the half is the total divided by 2. So the total is 2 plus 3. I mean the length of A is 2, length of B is 3, divided by 2. So it is 2. Yeah. Half should minus the split. If here the split, the index as m1, and m1 is 0. So half minus m1, 2 minus 0, it is 2. Yeah, but we need to have a position at 0. So if there is a 0 here, basically it means split. For the 0 index it is the left, and the 0 plus 1 index it should be at the right. Yeah, so it should be half minus m1 minus 2. Basically we need to get this kind of a formula. So this formula would be equal to m2. Yeah. So in this example, half is 2 minus m1, 0 minus 2. It is a 0, so it means here. So here is a split. Now we're gonna define some more variables. So at the left side we're gonna call it LA, left A, and this one at the right side we're gonna call it LB. So LA is 1, LB is 3, and here this number 2 we're gonna call it let me call it A left, or A left A and right A. Yeah, so for this one we're gonna call it right A, and here we're gonna call it left A, and for this one, this number 2, we're gonna call it left B, and for this number 4, we're gonna call it right B. Yeah, if we know all about those parameters, basically we can compare. If this left A, let me use another color. So if this left A, it is here, this 1 is less than or equal to this right B here. 1 less than or equal to 4, and this 2 left B is less than or equal to right A. So this is 3 is right A. Yeah. If this 2 less than or equal to 3, it means basically this line is a split of the two arrays. So 1, 2 should always be smaller than 3, 4, and 5. So in this way we can find the result. So if the total array, I mean A plus B, is an odd value, as it is 5, so we're gonna choose the minimum of this 3 and 4, minimum of right A and right B. And if it is even, so we're gonna choose the maximum from the left side and the minimum from the right side, and then divided by 2, we can get the result. Yeah. But because of this kind of a formula, it can get negative values. So, for example, if array A is empty, array B is 2, 4, 5. Let's check what's gonna happen. So if array A is empty, so array B is 2, 4, 5. So the total is 3 divided by 2, half is 1, and M1, there's nothing inside. So the left and right should be, left should be 0 and right should be 0. So the M1 should be 0. Yeah, as you can see, half is 1. 1 minus 0 minus 2, it is a negative 1. But we should not have the negative index. Yeah, so it is out of the range. So in this way, we have to do some paddings for array A and array B. So for array A, we're gonna add some paddings. So for example, we're gonna add negative infinity with 1, 3, and with positive infinity. So this is gonna be array A. And then for array B, I'm gonna add some paddings, negative infinity, and with my values 2, 4, 5, 2, 4, 5, and positive infinity. Yeah, so in this way, while I'm doing the split, it will never be outside of the boundary. I will always find the made value. I always find the median of the two sorted array. Yeah, I just do some padding and I can get the result easily. And we also need to put the array A. If array A is the sorter, we need to prepare nums1 as array A. If nums1 is bigger, so we're gonna define nums2 as array A. So what did I mean is that array A must be sorter in order to meet this kind of a formula, half minus m1 minus 2, to find the position of m2. Now let me go back to the coding to finish it. So as I said, I'm gonna prepare some paddings for nums1 and nums2. So I'm gonna prepare negative infinity plus nums1 plus positive infinity. Yeah, so in this way, it is still the sorted array. nums1 is still sorted, and also for nums2, I'm gonna prepare such paddings. nums2 would be the negative plus the positive infinity. Yeah. Now I'm going to define two variables A and B, and a total. So A should be nums1, and B would be nums2, and the total would be length of nums1 plus length of nums2. Why did I do that? Yeah, because later on I only gonna use this A and B as my two arrays. Yeah, I just wanted to reduce some coding for the variable, so I'm gonna turn the nums1, nums2 to A and B. Yeah. So if length A is more than the length of array B, so I'm reassign it. So AB should equal to BA, because I want to keep array A always to be shorter than array B. In this way, I can do the binary search calculation. So I'm gonna prepare the array A for the binary search. So L and R would be 0 and length A. Yeah. Now I'm gonna start the binary search. As I can always find the answer, I'm gonna use a while true, and then I'm gonna find the M1. It means the midpoint of array A would be equal to L plus R minus L divided 2. This is just for the binary search. And this is M1, and M2, as I explained earlier, we can use the calculation. So here I'm going to define a half variable, and it's going to be total divided by 2. Yeah. Now I'm going to use this half minus M1 minus 2 to get the index for array B. Now I can define four variables: left A. Let me define four variables: left A, right A, and left B and right B. Yeah. So in this way, the left A should be easier because it is always inside the boundary. So left A would be AM1, and right A would be AM1 plus 1. And similarly, for left B, it would be BM2, and right B would be BM2 plus 1. Why it is like that? Because because we've calculated. So for example, this is array A, and this is array B. Array B is longer, and we find some split, and here we find some split. If we find this at this dot, it is M1, and then this dot must be M2, M1 plus 1. Yeah, because in this way we just split the array into two parts. And similarly, if the split point, this is M2, and the next point would be M2 plus 1. Yeah. Now we just need to check if this one less than or equal to this point M2 plus 1, or at this M2 less than or equal to M1 plus 1, it means we meet the condition. If we didn't meet the condition, we can still use binary search to check. So for example, if this M1 is more than this M2 plus 1, I mean maybe this number may be bigger, so we're gonna shift the right pointer for the binary search in nums A. So we're gonna shift the right pointer to be M1 minus 1. We're gonna shift it to be here. Yeah, and then we're gonna check it again. Maybe the next split may be here. Yeah, if it meets the condition, we're gonna find the result. Now let's check the condition. So we're gonna check if left A less than or equal to right B, and also left B less than or equal to right A. It means we've already met the condition. We just need to check the total. If total modulo 2 equals to 1, it means the total length is odd. Yeah, because if it is odd, even we plus the padding with 2 and 2, it will still be the odd. We didn't change the odd and the even property of the array. Yeah, so the result can be the maximum. So we're gonna return the maximum of right A with right B. I'm sorry, it's gonna be the minimum because it's at the right side. Yeah. Otherwise, we're gonna divide it by 2. It means the sum value divided by 2. So at the left side, it's gonna be the maximum of left A and left B, and at the right side, it's gonna be the minimum of right A and right B. Yeah. So this is the case if we find it. But what if we didn't? So if this left A more than right B, yeah. If this left A more than right B, this is what I explained. Maybe here we have a value. Maybe at this dot we have a value of 8. Yeah. Maybe here M2 we have a value of 4. Yeah. If this 8 is more than 4, it means we have to shift the right pointer to the left. Maybe here is 3. If this is 3, we meet the condition. 3 is less than and equal than 4. Yeah. So this means the right pointer R should be equal to M minus 1. Else, so L should equal to M plus 1. So this is going to be the entire code. As you can see, we didn't do some boundary case checking because we added some padding. Yeah. Now let me run it to check. Yeah, I can not see the testing cases, but let me submit it to check if it works. This M, did it mean M1? Yeah, let me check. Oh, this should be M1 and M1. Yeah, now let me submit it. Index out of a range. it is line 15. Left A, yeah, this is a right A, left B, and right B. B should equal to BA, and this is total, and this is half M1 and M2. Yeah, let me just copy it in some other places because I cannot see the testing case. It is quite annoying. Let me just copy the code to another tab. Maybe, yeah, I can easily find how to debug. Yeah, because from there I cannot debug. Basically, I need to check why it is not working. Yeah, let me copy the code in the same place. So, yeah. So here it's the same code. Now let me test the result. It seems those two testing cases works, but there are some other testing cases which didn't work. Let me try to find the reason. So I'm gonna add this testing case and yeah, try to check. So it is out of range, the right A out of range. Let me check why it is out of range. I think I need to print this M1 and M2. Yeah, it is 1 and -1. Normally I should not get a -1. Nums1 and nums2. Yeah, this is out of the range. M1 is 1. Yeah, because I put something inside. Let me print out A and B. As you can see, this is A and this is B. It is okay. And M1 should be 1. Yeah, I think M1 should be on 0, but why it is 1? Yeah, here I did a mistake. It should be length of A -1. Yeah, because this is for binary search, I forgot about it. Yeah, basically this is a left pointer, this is a right pointer. It should be length of array A -1. Yeah, now let's try to run it. As you can see, it works. Yeah. Now let me submit it to check if it can pass all the testing cases. And as you can see, it works. Yeah. Now let me just delete this print and the print and to check the speed again. Yeah. I think it should be much faster. As you can see, it works. Yeah. I think this way it is much easier to to prepare some paddings like the negative and positive infinity and for both nums. And from here, we will avoid some edge cases checking. Yeah, so it's gonna speed up a little bit for our coding, and the logic would be easier. And the only difficult part may be here. From the index 2 for array B, M2 for array B, we have to use this kind of a calculation because we choose A to be the shortest, and we use this kind of a calculation. Basically, if we make some drawing, we're gonna find which position is M1. We're gonna use a binary search, and for M2, we have to use some formula to calculate it, and we have to use a half minus M1 and minus 2 to find the position where it is. Yeah. Yeah, I think that's all for today's problem. Thank you for watching. See you next time.